Okay, so here
Children. Class time.
We're sorry about that. We're sorry about that.
No, it's good. It's good. It's fine. Okay, guys. So, programming things today. I wanted because I know. Well, not for all of you guys, but a lot of people have been asking, like about algorithms to do some of this stuff more because if you go to like any software programming like thing, they're gonna ask you to do this, right? So we started easy with this type of stuff, and I got lead code, which is pretty good for like developing a program. And what I wanted to do is go through kind of like what I would do, but like I will show you what I would do to solve this algorithm. But I want to see what you would do first, and we can work through your problem on it, and that way I help you get a better understanding of like this type of stuff. Okay, and it's fun. It's like solving a little puzzle. Okay, so yeah. Oh, and he is also part of the club, and he'll join us here soon. So, okay, so you're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order. For each of the nodes contains a single digit. Add two of the numbers and return them as a sum as a linked list. That's like insane talk or whatever. But so it's easier when you see it on the little graph here. So this is supposed to represent a number, and the number is in burst. Okay, so this would be 243, and this would be 564, right? When you add them up, you get 708, right? No, the other way around. Yeah, it's the other way around. But yeah, so you get, if you sum them up, you would get 807, right? So how would you go about doing this? Like, what is like just the first intuition that you get? Like, okay, just start summing them up, or like what? What do you think? It's okay. No, we'll take your time to think about it for a second. But yeah. Yes. What? Is it? Did it die? You need to charge it. Put it on the charger.
Felipe, may I say, Felipe?
Yes.
I won't be here up to the end.
Sure.
May I say some words?
Oh,
Hey, coño, ¿cómo estás? How you doing, buddy?
Very good here.
Good, good.
oh, I'm doing algorithms right now too. So
Oh, cool.
yeah.
This thing here.
You are here also in the robotic club?
Yes.
Yeah. He's the algorithm guy. He likes algorithms.
Were you swimming?
He is my student.
I know.
No,
Yeah,
it's
you know.
swimming.
Okay, guys, my name is Manuel Carames. I am a professor of mathematics and the
Come closer.
advisor of the club. Then what do we do here? No, we do robotics. Now, it's possible, what is possible? No, we are trying to add artificial intelligence in our robots. And we secured a large amount of money already is secured. Felipe was with me, right?
Yeah.
We discussed about it. We are talking about more than $200,000, and you will see the equipment, a great equipment. Jonathan, there is the scenario for the self-driving car. We asked for that. We will get some drones, but drones that they don't need space because are fixed, and we will be able to create the control for the automatic pilot. It means without flying the drone, we will be able to learn about drones that we love so much. We will get some more, another robotic arm.
Right.
Maybe you didn't see the one that we have here. We have one, very good. We will have some 3 or 4 arms mounted in robots. It means our arm now is stationary. We will get robot, I think it was 4 robots that will be able to move and do several things. And the last but not the least, we will acquire maybe something that you didn't even imagine. is a stand for control theory. Control theory, Jonathan. It means in the industry, in the real industry, in the industry that produces good for the humanity, there are five key variables. They are temperature, level, flow, pressure, and no, I don't know, don't remember the next one maybe. And we will have in this time the same way that they are in the industry, and I know it because I was in the industry for many years. You will be able to have this here. You will be able to learn control theory. A very important thing, very important thing. And this is our map road. We have the good thing to have Felipe here. Felipe changed the image of the club. Felipe is a bright guy, a hard-working guy, and I know that many of you are bright. I know that. We will see. That the club will show us who can do what. And here is that. We will work, and that's it. Do you have any questions? Thank you, Felipe. Have a great day.
Sure.
Frank, bye.
I'm gonna go this way.
No, I go this way. Thank you.
Cool stuff. Thank you for the great speech. Fix it.
Great speech. Right.
Yeah.
Yeah. We need, by the way, we need girls, you know.
The what?
Girls here.
There was girls at some point. I don't know what happened to them.
Yeah.
We had a girl, right?
Yeah.
What is she?
She's in Mexico right now.
Huh?
She's in Mexico.
She's in Mexico, but still
I know
with us.
someone. That's
What is it? You know some
I know
girls?
someone, yeah.
No, I don't know about it. I don't know about it. But I need to, I'm
she's
talking about
interested in
girls that work here with us. Guys, may God bless you. May God bless your family. Have a great day.
Sure thing.
Gracias, Fernando.
All right. So actually, one thing that was cool. First time that happened. So cool stuff. So I always find that is for this type of stuff. It's good to have somewhere to put it so you can this type of stuff is all numbers, right? But it's easier to interpret it more visually. So if you ever have to do something like for real, draw it out is probably a good idea. So something that I would suggest because it helps you having an actual paper and I have this fancy.
So, wait, let's go back to the thing.
Oh sure, yeah, okay. Oh yeah, you guys probably forgot.
That program. That comes in clutch when it comes to exams.
Yes. Okay, so.
So you're given two lists. One with integers. The two of them have integers.
Yes.
And then you have to. How I would do it is I would convert all of them into strings, and you add.
There's multiple ways.
No, there's multiple ways to do that. That way is horrible though, but it's okay. Just say the data when you try to when you're going and completely okay. I don't mean to I didn't mean to. Something that you want to avoid. You should in this performance the dependent operation that you want to make as efficient as possible. The translation between integer to string is very inefficient, very efficient. There's only on. I'm a JavaScript developer. I do a lot of JavaScript. Usually that's done a lot in JavaScript because you're translating a lot of because a lot of display things a lot of time you're translating a lot of integers into strings to display them for whatever reason. So that has a lot of JavaScript, but it's not really optimal for more performance applications. Things that you want to do in robots, especially because you want them to be responsive. You want it to be as fast as possible. Also in games, if you want to be a game developer or a game development is probably I would say it's only some game game development and I guess artificial intelligence is the only two places when you use all the super esoteric computer science concepts
Even then, there's game engines for games.
But you don't want to. But that's the you want to be able to do it yourself because that gives you more control. Like obviously, yeah. Oh, I can just get like Unreal Engine, I can get Unity, and it does all this stuff for me. But like, if you want to do that, you can.
You want to learn.
Well, no, it's not about that. It's that like if you want to do that path, then you should be a designer, not a programmer. So like that's the path of the designer. If you want, I mean, go and take an art degree. Just saying, because that what you are going to be working on there is nothing to do with programming. Really, it's mostly art, which is cool. I love art. I love doing this stuff myself too. But this is more for programming, right? Which just saying like that's a part of the whole thing. But yeah, going back to this. So you say okay. So let's think about what we do when we convert it to string because that's an operation, right? The operation that you do, well. How would you convert it to a string?
I mean, there's multiple ways. It's just one that you could do it in a single string. All of that you could program it. I mean, I program in Python. That's why.
Yeah, it's okay.
C++ is the headache.
We can do it with Python too. Like it can be done on anything. But the thing is, if you want to do it in Python, we can run in Python.
I mean, for in Python, like for example, the shortest path is just convert it to a string and add the two things and then convert it back into. And
so I don't do that much Python. Is there a method to do? So L1 is the list one. So L1, and then what do I do after that?
So you have to put L1 equals int. So it knows that is it an integer?
It's
int L1.
Int
Within parentheses and L1.
Int. Oh, in parentheses. You wanna come here?
Sure. I mean,
go ahead. I mean, no. If I can learn some Python from you, I'll love it.
yeah.
Go ahead. No, I mean, no. This is good because this is.
So
Yeah, this is how we learn basically.
since you already have L1 and L2, you don't need it. But you can put int L1 plus int. No, sorry, I'm converted into an integer, so it needs to be a string.
And can you log that real quick? I want to see what. Okay.
Yeah. So okay, let me explain this. So the output is just going to be I'm assigning this variable right here to the sum of the string. So of the whatever value this is converted into a string plus the value of this converted into a string. What that's going to do is, for example, that's going to have, instead of being wait, I'm sorry. This is a list.
Yeah. So
No,
No, it's
sorry.
okay.
Let's just put it wrong. Yeah, because what it was gonna output is 2, 4, 6, 5, 6, 4.
Yeah, that's what because what I
Yeah.
thought was gonna happen is that if you do it to string, because I was wondering if that was gonna happen because what it needs to do because it will get two it will I wonder if it has this method, but it will get all the numbers and then it would concatenate them into a string, right? And then it would concatenate the next string. And what I thought was gonna happen is it was gonna get like the entire row of guys there, but.
So then you have to get L1.
You're
So
saying
since
like
L1
convert
is
it to string to integer.
Yeah.
And then back to
the string. Yeah. But, I mean, you could do it that way. I thought it was gonna be shorter, but I don't know why I thought that way. But the other way to do it simpler is just like do a summation, essentially. You do.
How would you do that summation?
Okay. So how we do it normally? So 5 plus 2, it's gonna be 7, right?
Mm-hmm.
So whatever if we just get the first digit, not the second one. So if it's like in the second case, just 10, we get the 0 and leave the extra 1 for this.
And how will you store the other thing?
I have another solution for that.
You go after him, okay? So we'll take turns. No, it's good. So yeah, but okay, so yeah, you want to give it a try? Give it a try. Yeah,
Sure,
go
sure.
for it. You're doing good. And then you can. So, another thing. So sorry. Okay. Tell me again. get 6. Yeah. Yeah. What you have to do is like they both represent numbers, right? And I think he has it. Let me see. L1 plus L1. Let's see. The one thing is that if you do it this way though, keep in mind that you have n numbers per list. So it's not 3. It could be 1 or it could be 1 billion.
Right.
So
I mean,
you need
yeah.
to do a loop. You need to do a loop.
Yeah.
Okay, so no, in this case it's 0.
Yeah.
This is the first interview. No, I'm doing it this way because I'm telling the program that I want to get the first digit, which is this one.
Right.
2. So it'll be 2 plus. Okay, so this is the first digit.
Oh.
It would be.
You were looking for Richard.
Hey.
Yeah. Come on, man. You wanna partake? Yeah.
Hey, Richard, I left. Remember, I left like a week ago, 2 weeks ago, something for physics printing on your. Is it finished already?
Yeah.
Can I pass by it after? Okay. So, all right, the first digit is gonna be the sum of these two, which is gonna be 7. All right.
Yeah.
Okay. But then I have to tell the computer, right, in case the thing is greater than 10, right? It's greater than 9 actually. To split it into 2, and for the for the first digit to then pass it on to the second, which is complicated because then I have to do an if else statements, all of that.
There is another way to, modulus.
Modular?
Yeah, you know that.
Yeah, which one would I import in here?
So think about this. So, what is modulus?
A set of, it's a set of commands already, right?
No, it's an operator. What modulus does,
It's a remainder thingy, right?
yeah, it gives you the remainder of a division. So basically, if you divide anything by 10, what do you get?
Something in a remainder.
So if
Yeah,
so
you move the
actually, wait,
period.
hold on, am I stupid?
No, you.
I think I said no, yeah. The remainder is the thing is that one thing that you got is but okay. So how will you get the second digit though? Like what will you do for the second digit?
All right, so I need to get something here that gives me that extra digit, right? Because we're doing a sum, so it would be 5 plus the 2, which is 7. But let's say in this case it was 5 and a 5, so it would output a 0. But we have
5 and a 0 and output 5 and a 0.
Wait, give me a second.
I was thinking that over there. Because I would have done the loop. First thing was like the loop, and then
Actually, never mind.
the position. But you could put it to a stack.
So the first digit has to be the last one. 'Cause
What do you think? You got something, Fernando?
Yeah, let me write it.
Okay.
Wait, can you explain how would you do with modulus again?
So, quick thing so look, modulus always spits out the remainder, right? So when you are, because there are integers of only one number, right? The max value that you could get is 99. That would be 18, right? So let's say that we have per se like 99, right? If you get 18, modulus of 18, what's the modulus of 18? 10. So that would be 18 divided by 10, right? It gives you 1, but what's the remainder?
Okay, if you take the remainder of any number
Yeah.
with 10, what you're gonna get is
The first number. Yes, you get 8. Yeah.
Yeah. And the remainder is gonna be the last digit. So if you divide 88 by 10, it's gonna be 80, and then the remainder is gonna be
Yeah, that is to get the last number. Yeah.
yeah.
So if
that's
it's
the number that you're gonna pass on. You know?
yeah, so if it's bigger than
Then
9,
add.
you have to do the modulus basically. Yeah.
Then
Any
add.
number bigger than 9, you do the modulus. So and that's how you can store as so. Yeah, you say if first digit greater not 10 because 10 is a number that you don't want.
9. It's for that.
Oh, it's
one,
in
you have to
reverse
make it
order.
Greater or equal?
Yeah.
Greater is greater or equal is trash because you're doing two things.
No, greater than 9, yeah, greater
Yeah,
than
you
9, sorry.
want to do greater than, like greater or equal is only good on certain occasions. You want to do either greater or lesser than. Greater or equal is generally for like super specific things. For most things, if you would do recursive, just plan ahead and never use greater or equal. So you would do greater than 9 because there's no middle ground. You don't have any.
It's binary. There's one.
Yeah, yeah, it's either 10 or it's 9. You would
Yeah.
never have like a 9.5. So yeah, yeah, exactly. That's good.
You won't check for decimals.
Yeah, it's not decimal. There's
And
no
also,
zeros.
if you divide it by 10 instead of doing the modulo, you will get the first number always.
You divide by 10. If you wait, yeah, are you more right than me? I think you are. Wait, if you divide
If you divide
Wait.
88 and 6 with 10, it's gonna be.
what happens if you divide?
It's gonna be 8.
Am I s- If you
Yeah,
divide
That's what the modulus is.
8 divided by 10, what do you get? 8 divided by 10, you just get 0, right?
No, you.
Oh,
you
yeah,
get 0.8.
Yeah, no, yeah. It's,
You get 0.8.
What?
Because 8 divided by 10 does the remainder 8.
Yeah.
No, but no remainder, just
So you
divide.
need that remainder to pass on that remainder and the divisions to see how much you're gonna add to it.
No, but but the thing is, okay.
It's never
So
gonna
think
be
about this.
the
I'm trying to find out one operation that does everything. That's what you want to try to find. So no, I don't think you're right for that one. But I'll tell you why real quick though. So what I was thinking is that if you have, let's say that what would be great is that one operation that does everything. So it would be, let's say that we have 8 divided by 10. If it gave you 8, it would have to give you 0 for the remainder, right? That's true, right? But if you divide, let's say 11 divided by 10, that gives you 1, right? But if you do, I don't know, if you do 12, 12 divided by 10, it gives you 1 too. That's not the remainder. Make sense?
Right.
And
But it's the number that you're gonna add to the number after.
that you can just use the index.
Right.
Because every time you go up is like it will be the index times 10.
Okay.
So however far away, so for example, this number right here would be 0 times 10 plus the number. No, it will be index times 10 times the number, right? So if the index times 10 is 0 times the number, it gives me just wait no. What am I doing? No, 2 times. No, it's times the index. If the index is 0, what am I doing? Index. It's not plus that, right? No. Hold on. I feel like I'm but. Oh, you're almost there though. What's that? Oh yeah, for the thingy. No, wait, hold on.
What?
For the 0, you're using parentheses for the 0.
Oh.
I think they're all just going to be. I guess. I don't
Oh, yeah, he caught you there. Nice. Yeah, good.
Like with the cafeteria, they're going to do underneath that little. So,
So
they're
okay.
going to be squishing
The other line too. Fine.
Yeah, the one below it.
Yeah, like what was supposed to be. Yeah, so it's
Right, so it says indexing.
So I looks like you cannot do that because this is not a array.
It's not passing on the.
Yeah, you gotta use self bottlenecks. You gotta basically do a constructor.
I just came to the
Uh,
really fun.
Well, what else? It says first number.
Is look, so what you can do self bow and self next. You see there on the top?
Okay.
Self bow.
What is self?
You know, have you done much object-oriented programming? Done anything like that? So it's basically a reference to the object itself. So like it's if you have an object, you're referring to what the object is, basically.
Alright.
So you gotta go.
Yeah, you gotta go too.
Yeah, I gotta go.
Okay, it's cool. Well,
We'll see. We'll find out if we actually have to open today, and then if not, we do it. Sure.
Uh,
I was just
Because we're sorting, and today's a field day.
I can do an example though. I can
Felipe,
Yeah.
What's up?
in Python, you're supposed to write append at the end of like every.
No, you gotta do self bow and self next, basically. That's how you refer to the next value. Is because it's not an array, it's a linked list. So you gotta skip. It's like you have a map. You have a map that is linked to. That's why I say that it's better to do it with a graphic before the first.
I'll go when things.
Come back. Yeah, but yes. Come back later if you guys want. But yeah, cool. I'll show you really quick what does that mean. Okay. So look.
Let me go and pick up stuff from there.
Sure. So look.
It's confusing. Like I'll try writing like the semicolons and stuff. And
Yeah, no, it's good. I will. Okay, so look. So we got the numbers set up like here. Okay. So and the only way that they can move is down this way. Oh, well, it's actually so weird to write. Okay.
Can't you touch the board?
This board? Nope. No, it's not
That's
touched.
hilarious. They spent so much money on this.
Yeah. 1, 2, 3. So yeah, the only way to go is from here down that way, right? So let me show you. What you gotta do is this. And I think I can do it in Python. Let's see. Let me challenge myself to try to do it in Python real quick. But let me explain what logic I would use to do this. Okay?
You would
So-
iterate.
What?
You would iterate first, right? The position.
Yes. So one thing that Brodsky didn't do there was he needed to do a loop. Okay, so that's important. You never want to use just for this type of stuff. If it tells you, thing that you need to always think about, if it tells you n values, meaning that the values could be either be 1 or 1 quadrillion. Okay, it's obvious that you need to start with a loop. It will have a loop because the loop needs to go through the entire set of values maybe it's a search or something, but you gotta think that yes, it needs to have a loop. Okay, so that was a mistake that I saw our friend there do, but yeah, so let's start with one of those. To do how do you do it's 4, right? You do 4 and then you would do
In range. Yeah. So X in range of
parentheses.
right. Oh yeah, so it's and then this is I think I remember. So this would be num for num. Actually,
Yeah,
wait.
the word. Put for the word and then.
yeah, for num in. Oh no, I think. Oh okay, no, I think. Wait, hold on. Let's see.
it's
What?
like this.
Right, no,
And
but
then-
the thing is that that's not how this one works. So let me see. So what? While. Oh, I know. Okay, is it basically this? Look at this.
Yeah,
It's-
while loop.
Yeah. So you gotta do while self dot next is not equal to null. Yeah. So yeah.
You can also do an if statement, no? If. it's
That's
not
the
equal-
statement.
Yeah, but like.
Anything that you can do on a hi.
Hello. How you doing? Hey. Doing some out.
You can do in a for loop. You can do in a while loop. It's just a while.
Well, yeah, but yeah, that's but yeah, basically is that if whatever the next value is gonna be, if there's nothing there, then you just don't add it, right? Also, we know that it's in burst, right? So 243 is 243, and 564 is 564, right? Right, I think so, right? Or
Yeah.
oh, actually, hold on. 5. Yeah. 5, 6, 4.
Yeah, you're right. Explanation's right there.
No. It's actually the opposite. No, I'm wrong with that. 4.
Why? What are you trying?
Oh no. Yeah, you're right. No. Okay. No. Cool.
You can add it and then reverse it.
Yeah. What?
How the lists are both the same size, or not?
Sorry. What?
The list is the same size. Like both are the same size of each other.
No. So. Oh yeah. Okay. So yeah. No. There's a function. The thing is, I'm not used to programming in Python, but I want to try to do it for this. But yeah, actually, this is wrong. So you have self list. Okay, yeah. So what you would have to do, you have to do L1 dot. Yeah, L1 dot next is. Yeah. Wait, we do it on the next, or we do it on the self. 1 second, let me think. Next. No. It's L1 dot bow. Yeah, L1 dot bow is equal to null. And you gotta do an and or L1 bow is not equal to null. So yeah.
You missed the dot.
Yep. So you do while L2 dot bow. Alright. So this should go, this thing right here should go for as long as either of these guys has a value. Okay? So it will keep going through their data tree as long as either of them has a value. So if we think about it in the little graph here, okay? So think about it this way. Just let me delete this whole thing. So think about it this way, okay? This is why it's kind of useful to think about it in little values, okay? Let's say that this one, this one right here only has 3 values, right? So you would do this plus that, this plus that, this plus that, and this plus that, right? Whatever it might be. So this, let's say, whatever value it might be, right? It's actually so hard to type in here. I'm not gonna do it anymore. I'm just gonna do it on the top, okay? I'm gonna do it with these little guys. Probably better. There you go. Much better. This. So let's say this is gonna be 1, this is gonna be 2, this is gonna be 3, this is gonna be 4. I'll do the same for this. 1, 2, 3. Okay. All right. So you get the sum of this. You would get a 2. Actually, let's add something just for the sake of. Let's do a 9 here, just so you can see what's gonna be actually happening. So this is the situation where that we want to kind of plan for. Okay. We have one list that is longer than the other, and we also have one value that is going to get carried out. So we have most of our contingencies. We have thought about most of the contingencies. Maybe there's another one that I'm not thinking about. Whatever. So this would give me a 2. This would give me a 4. And this would give me what? This would give me a 12, right? This would give me a 12, right? This, what should happen is that it gets carried out to here. The 1 gets carried, or you should put it.
The 4 gets carried out down.
Yeah, exactly. This gets carried out here, and this will be 1 plus 4, right? Yeah. This will be 5. So the answer should be 5, 2, 4, 2, right? So one thing that I'm thinking about though is one operation that I don't know exactly right now, but the operation that I'm missing is how do we make it so every time we use modulus, right? We get the remainder. You get a remainder.
Wait, I have a question.
Yes.
Okay, so right, isn't it 1 digit? Why did you put 12?
It's because I'm saying that I get 12 here, right? But what I'm doing is I'm keeping the 12. I'm keeping the 2 here. I'm carrying the 1 up here.
Right.
So it's just the output. It doesn't like So this is what's supposed to output, and then whatever it's over, he's gonna move over there.
Okay. I mean,
So-
yeah, but like, it should be like.
2.
I'm gonna put one here. I'm gonna put two here, right? And then I'm gonna say that this guy right here goes there.
It's like I usually don't add left to right.
But yeah, the thing is that that's how we kind of have to do it, right? No, but the thing is that we are adding right to left. We're adding right to left, but it's because the numbers in burst. Because this number is not 1,234. It's actually 4,321. We're adding the way that we normally add, but because the machine has to add one way, right? Like machine only reads one way. The machine only reads from left to right. We have to invert our list in order to do this. Does that make sense?
Not really. So we shouldn't be adding the other way around.
So let me show you that. Okay, so look, way that I would add a number, right? So let's do 4,528, whatever, plus, and then I do plus, I don't know, 356, okay? Right? So the way that you would add it from right to left, right?
Right.
Right? But machines only work left to right.
Right.
Right? So in order for us to be able to do this sum, we need to basically spin the numbers around and then sum them.
Okay. Yeah.
Makes sense, yeah?
You say that last part again. I'm sorry. We wish.
Christian left his class.
So what happens
machines work from
left to right? We would switch the numbers in reverse,
Okay.
and then give it to the machine, so it does all the math, and then it reverses back to us.
Right. Okay. Okay.
Yeah. So yeah, you got it. So yeah. So let's see. So now back to this. So what we gotta do? This is something I haven't done exactly myself. So I think that I have to do. What's up?
Nothing. I'm gonna take note of this so I can review it.
Sure.
Yeah.
So here we have L1 val null. So if this both are equal to something. Oh, but null in Python has to be like capitalized, right? Null. Is it like that? Do I have to do that? Null in Python?
Wait,
I probably should do this on JavaScript just so I can get it done. But I mean, it's good to learn.
Pretty sure you also just make it equal to 0 or not.
No, because I think that if it's equal to,
'Cause I'm pretty sure
it's possible. It can be equal to 0 and be valid. Like it could be 402. This 0 is valid, right?
oh my god, it's more stupid.
Right. It's fine. So let's see if this works real quick. So it would.
That shouldn't.
So let's see. In wait, what?
Instead of no is none.
None. Oh.
And instead of equals, it's like is.
Oh yeah. I hate Python. Oh my god. That's horrible. Okay. Thank you. Hey, thank you for that. Yeah. This is not a real programming language. You gotta be joking.
I was just thinking about it. What the heck is that?
They use none. What?
Dude, this whole time I was like, what?
You guys are.
No is none. If you haven't.
Dude, I'm literally just starting in Python. I'm like, what the fuck is no?
Yeah. Okay.
Language is, like, way too high.
Yeah. They are rotting your brain whenever they use Python, dude. I tell you.
Every other single language, it's no.
Yeah. Python they use.
No.
Oh, so C++ and everything else.
Yeah.
Oh,
JavaScript is null too.
right. Python is free.
Well, no, JavaScript it will be undefined, but yeah. Okay, so let's see. So let's get an int of the values. So we'll do L1. We'll do L1 dot val plus.
and also that or, I think it's written or.
Oh, really?
yeah, I was also saying, what the
Yeah,
fuck
you're
is that?
supposed to say or as
Oh,
Yeah.
well, there you go. Okay. Okay, so do I declare integers like this? Yeah.
Keep on writing it.
Integer.
Wait, it's not. How do you write
res-
is not? Because that's supposed to. It's
Inte-
not. No.
That's how I do an integer.
No, you should put result is equal to and then put integer after and then put it as a
Okay, he's mean, right?
Result is equal to what?
Integer.
L1 dot
No,
val.
no,
No,
it should be like
integer.
Oh, you have to
int, open
concatenate it.
parentheses, L1 dot val plus. I'll show you.
You need to put integer first.
I need more practice on Python, dude.
So this is like a little bit nene, but
Nene.
well, it should inherit the data type anyways, but it should be like this.
Is your first time?
This is L1.val, right? Plus,
Yeah.
and then you just delete all this crap.
Oh,
It's supposed to be an int.
I'm pretty sure it's like just return it.
Okay, so I do the L2 dot L2 dot val. Okay.
Yeah, because in Python, they hate it when you declare values for some reason. You might also have to declare results.
Okay.
But
No, because I only use it here. I only use it every.
So just use the regular is not equal, because that means is just means equal. It's so fucking weird.
Okay, so like that.
Yeah.
Oh yeah, and I had to do is not, right? Yeah, whatever. So yeah, equal. Okay. Well, I guess we're learning Python over this. So then I will do if.
Wait, but no,
So
the color is not changing.
Hey, I searched it. It works in Python 2 and Python 3. It's
you
like
have to put,
output.
I think we have to put parentheses around this as well.
no, you
No?
don't. That's what I know. That's some wacky stuff. Some wacky Python stuff. So if result is a smaller. No, if result is
Like
greater than
example.
9. Yeah, if result is greater than 9. Okay, yeah, there you go. If result is greater than 9. So that's the thing that he got right. If the result is greater than 9, that's correct. Then okay, this you gotta save before here. Actually, yeah, you gotta save it in a value outside of this. So you do you would have to do carry is equal to 0. You have result, so then you do. If result is greater than 9, you would have to do carry is equal to
What are you doing? Isn't that your major?
so
Computer science.
modulus.
Here?
No, what? This is my second term, West Campus.
West Campus.
Yeah.
Oh, so you're getting your AS. Fucking late.
AA.
AA.
Yeah, double A.
Yeah, your AS.
What are you majoring in?
Bachelor's in
I do
in software engineering.
Do you guys figure it out?
Yeah. So the
What?
thing that you have to do, something that
Bachelor's
you
in software.
that I was trying to hint at you to do this is that you needed to do a loop, some sort of loop, because the n value, that's important. Okay? So if they ever ask you for n values, know that you will have to use a loop, because values could be either 0 or like it could be 0 or 1 or 1 quadrillion, right? So you have to because if you start using the actual index, like you already kind of like messed it up. But it's like, now because it's the linked list, it also doesn't have an index.
Oh, that's brilliant. I like that line.
For how many years have
I really like that line. Okay, that
Yeah.
solves a lot of things.
Yeah, exactly. So and I was that's why I also told you that something that is good to do. Wait, what? Pigeon. What a fun fact. Oh, what the pinion? Who's that? Oh, thank you. Oh, we got a chatter. Oh. What a fun fact. Thank you, man. Okay, so something that I want, why I told, I said that it's good to graph this type of stuff, it really helps.
It is.
Yeah.
So when I do it like this, look, I can kind of tell what's going to be happening, so I can make it easier. Because they said, like, what if the lists don't have the same legs, right? Because that's like a thing about that, right? They both need to be also none, but let's say that this list is way longer than this other list, right? This just starts getting carried out and it's fine, basically, right? You will just do the sum of this and it will be cool, right? Now,
One thing you gotta, it's reversed. So you gotta have that in mind. The lists are reversed. So
reversed in from what normally. So we were just talking about that. So look at this.
can you draw on this?
You can draw here. If you want, yeah. Oh, but you can just use that too.
Oh, whatever. If you have like
So
that
the
list,
output is
it's
2,
1, 2, 3, 4. The actual number that you're gonna get out from there is 4,300.
So it's
That's the actual
one
number.
by one.
Yeah.
So-
So it's reversed.
Yeah.
Alright.
So
That's
because
what I'm saying.
how do you usually add from
Our problem
the
is
right?
figuring out how to
Oh, we were
figure
just
out
talking
what
about
out
that.
here.
Oh, when you
So
do
the
sums,
machine
right?
that it's
You
doing
do
is
it
going
we
you only
do it
carry
from
ones and
right to
zeros?
left, right? Machines
Well,
only
there you
go
go.
left
The
to right.
machine, what we wanted to
In
do is
instructions, right?
go by
So
each
if
column.
you reverse a normal number for us, it's the normal
And
number
every
for the machine.
column is gonna output.
So if it's reversed, then it's the right
this is
way that
2,
a machine
this
would
is
do
4,
it.
and this is
And then
12.
you interpret
Now
it
ours
again,
is here.
then that's the
is
way
how the fuck
that
do we
the
carry it
machine
out?
would.
This
Like, so that number, so we got
this
what
column
that
we
number
have
would be
to, we're
five-
still trying to figure it out.
I mean, you can just pick the number 6 next to it.
5,242, right?
It's not that easy.
that read
So
out
we
to
have to
us,
do
that's the
some
right
fancy
result
trick with a
because we're
mod.
inverting it again as the result. So
Oh.
this is like a compiler problem in a way, right? So this is what like
Where
deep
we
down the computer
I
does to
forgot how
like,
it is, but we
do
get the
sums,
remainder.
right?
And if it
So
equals- if
basically,
it'll
you
equal
never
first
have to
value,
actually.
and
You, this is
you
abstracted
put it
for you
here
in
with
the
this.
normal sum, but it's good to know because if you
So if
we
the
have to
remainder
ever
is
deal with a
is
problem
one.
like this, and you do it like the super like you know like
The remainder
just bash with hammer
is-
type way. You
Alright, so
get
it's
way
like
less.
the
This is like
percentage
as
sign
optimized.
is
as
the
it is.
modulus. So
Yeah.
I
No,
think,
I know.
No, I
numerator
really, really like that
dividing
95
to
and
divide
No, but yeah,
I have to actually have to leave to the thing.
no, it's good, but yeah, the thing is, come on, come anytime. I wanna do things like
What
this.
days you guys meet?
You also have to
Thursdays, Thursday at 3.
So wait, so you're saying 12
Yeah.
divided by 10?
Thank you so much, okay?
Have a good day.
grab the first digit.
Okay.
You would grab the first digit and it,
I still don't
place it to
understand
next
the
one.
problem at all, but
So one.
Oh,
I wasn't paying attention.
What are the remainders?
What
The remainder is 2.
I can explain it to you.
So you decided.
We're not dividing.
This?
No.
This is modulus.
Oh, go ahead.
No, physics, yeah.
No, there's something. What
it's
I
kinda
want.
weird.
You want me to explain?
No, I-
Okay. Okay, you give me a pen?
Oh no.
Okay, whatever, just do it,
No,
look.
no, what I
So
want
like,
to show you
okay.
the system.
Just look at what I'm thinking.
Yeah, but
You see what
I
I'm
just
thinking?
want to,
Right?
know how like, the bits
So
work.
12
Oh,
minus
no,
10
I
gives you 2 as a
I
remainder.
just wanted him to see the system working.
So now what do you do?
Oh,
It's working.
Let me see.
I thought you just stopped there. Like 12 divided by 10. Yeah.
So let's say 12
well, now you
the
can
modulus, it's not division.
that's questions that you can think about, right? I mean,
No, but it's eventually the remainder.
Can I
Yeah,
use
well, it's cool.
programming?
Well, something for that we should definitely do. That's why I was trying to set up the
Really
pie.
now?
Oh yeah, you
So
gotta
I
give
believe
me
it's
that thing for the pie so we can.
Yeah, I
12
a few things
divided by 10.
Looks like 5 items on it right now.
Calculate.
Uh,
Give us
All the
one.
pies are stopping with this.
I was fine.
Yeah,
Did I do
the
this
whole
wrong?
amount, that's really high.
I
Oh,
saw
give us
some
last
for
week.
like $40.
Okay.
I guess it's cool.
So it gives us the last digit.
Oh no, like we're gonna
Then
get,
we-
Carmen says we can get like the
Then we would
$100,
store the
like
last digit in this
super
array
stuff.
and then carry would equal to the other one.
Yeah, I guess so.
Oh, we can get from Can.
How do we do that?
Yeah.
But so it is 2.
Those
Yes,
are the
yeah,
juiced
no,
up
fuck.
ones, the ones that come with all the accessories. and everything.
My brain is.
It's right.
Raspberry Pi.
Oh, it is. I have.
Raspberry Pi with like the one with 8 gigs of
Bro,
RAM.
I have no
the-
experience, bro.
Yeah.
I have no
Look.
sleep.
So yeah, we're
Okay.
gonna get those.
It's a little bit expensive.
Yeah, I'm fine.
So you get the last
This
two,
school's gonna
and
pay
it
for
carries
it.
into one.
Yeah. Well, there must be a tutorial. Why are we?
No, we're trying to figure out by
I think he
ourselves.
sent- I think he sent.
I know.
No, I think he sent something
There's a
today because
tutorial,
I was talking with him.
Obviously, yeah.
So he's gonna buy 4 Raspberry Pis, 4 Bs with the 8 gigs. So he's already getting 4 of those. But for the what we and I forgot, we need those like those displays for the IP. Like that solves everything. But we just need. That also means that I have to add that to the OS, so it's on all the OSs.
Sounds like a Docker problem.
That's true. That is actually true.
Felipe, we need to talk about planning for next semester because we didn't do any activities.
Oh right. Oh yeah. So we got a couple.
Yeah,
planned right now.
we have an activity, but it's not fundraising, and we are supposed to do one for fundraising. For
Yeah.
The thing that Alex wants to do, we could do that for racing.
Airsoft.
Airsoft?
But
Yeah.
how are you gonna raise money from that?
We come to join us, and because we organized it, we just mark it up a little bit, and that's it.
The what?
Airsoft.
It's like paintball. But like,
Okay, but when are we gonna do it? We have to set up a date.
When did he
We
say
have-
we-
Because
and
that's
I
not-
talked to him. He
listen,
said,
we have to fill out forms.
he
We
said
have to request permission. We have to, so it's not like one day we just say, oh, we're gonna do it and that's it. I need you to sit down with me, tell me the date, because I have to fill out forms. I have to do.
You guys, let me do this. So yeah, let's do it.
Yeah.
Okay. What?
If you guys like, I mean, Fox has the program.
But if they do something,
let me tell you what
Fernando,
we're gonna do.
announce something,
Yeah.
because Fernando's gonna be doing an activity next Friday.
If you guys would like, you can go back to the lab and then we can work on
Everyone,
Oh.
now that I have your attention.
Yes.
Yeah.
Next Friday, there's this it's finals week. You know, you have it either next week or you have it one after. I'm organizing an event we're doing under the math department.
Uh-huh.
Where we're gonna have a fitness incentive event. You know, it's proven that doing some exercise, even if it's like 20 minutes, helps you focus and it's better for you in the for the exams. So I wanted to do that. So we organized that. We already have a plan. It's gonna be on Friday at 3 p.m. So like if you guys can come, that's amazing.
Where's it gonna be?
Huh?
Where are you gonna do it?
We're
Where
gonna do
are we
it
doing it?
on the BMBC logo around the science complex.
In front of the science building, you know, that by the lake there's an
Right.
NBC logo.
Okay, yeah, sure.
We're gonna do a little routine. Like it's gonna be the simplest thing ever. I just want anyone to be able to do it.
Mhm.
And then we're gonna do a 1 mile walk. If you can complete it, nice. If you think
I thought we were gonna do some Arnold Schwarzenegger type stuff.
no, it's gonna be easy.
Come
It's gonna be easy. I want anybody to do it. Like honestly, if it was for me, like 1 mile walk is like literally nothing to be completely honest.
I'll try to come.
But if you guys can
Gotta
come,
aim
that's
for it.
amazing. I'll probably put like
You
a
have to exercise on
a
one day
button
of the year.
accepting donations for the robotics club because we do want our shirts and we need money for that. Right now, if we did it without no fundraising, we only get a $100 credit and we would have to pay like $25 each single person. You know,
Yeah, we
that's
need to work on that because
we could do
supposedly
less.
as a club we have to do at least one fundraising every semester
yeah.
to stay active.
What?
Yeah, and honestly, what we can do.
It's not. It shouldn't be that.
Yeah, I got an idea for.
No, but we didn't do it this semester.
But
We-
let's
we-
do. Well, I mean, I
So
didn't know
that's
what.
why it's
I can
important.
put-
Why is that a requirement?
It is a requirement.
For this
But-
campus, right?
For any time.
Let's do it. Let's try to get it done. I because I already have someone that's doing it. Something. Just
When?
I don't know exactly when, but I guess that depends on you now because now depends on how fast can we.
It depends on me, okay.
How fast can we fill out those forms?
It needs to be by today to like, probably get next week.
The thing is, you have to do it, like if we're gonna ask for refreshments, it has to be done with 2 weeks in advance, because if not, we have to talk to the student themselves.
No refreshments.
With campus services, I might be able, because of my contacts, I might be able to, but it's at least 2 weeks ahead. You
Okay.
see?
Yeah, that should be fine.
So but we need to plan something, and then Fernando came to my office, we set up the time, and then we have to create a flyer, we have to send it for approval. It's not from one day to the other one, we have to plan it, and we have to decide how are we gonna market it. So, it's not like I'm telling you.
Procrastinating.
Yeah, so, and that's why, I said
That's
it,
fine.
you remember that I said it at the beginning, let's talk about it.
Yeah,
Yeah, I just.
Yeah.
This
Let's-
is-
let's-
this guy
let's-
was-
yeah.
we got people that wanna
And
work.
you know where I am, so he,
What's your name?
Pilar, I'm Pilar, from the math department.
So the
I used to-
No.
I used
Pilar,
to
you
wonder.
told me Pilar.
Like right now.
The fundraiser was nothing. We
I
had
have
to
time.
meet, we
Yeah, I
had
have
to
some
meet
time.
activities like
I'm gonna stop this.